Just to go over a couple of logistics, the chat is closed. Please use the Q&A feature at the bottom of your screen and be aware that only you will see the question that you've asked. We have people on our side that are monitoring the questions, so be assured that your question will be seen. Today's talk will be moderated by Dr. Jennifer Marlon, my wonderful colleague. She's a research scientist here at the Yale School of the Environment and at the Yale Program on Climate Change Communication. She obtained her PhD and MS in geography from the University of Oregon. She studies public perceptions of and responses to environmental change, particularly extreme weather events. Examples of her work include the Yale Climate Opinion Maps and a study of how hope and doubt affect climate change mobilization. She's published over 60 peer-reviewed papers in top scientific journals such as Science and Nature Climate Change. Her work has been featured in publications like the New York Times, Forbes, and National Geographic, and has been applied by practitioners and organizations around the world. Please let me turn it over to Dr. Marlon now. Thank you.
Thank you so much, Lisa. Hi, everyone. I am very pleased to be here today. Thank you all for coming, for tuning in. This is a very exciting lecture, and I'm very pleased to be moderating it. And the Yale School of the Environment Data Science Initiative is very pleased to be supporting our speaker today, Chris Mooney. Chris Mooney, as many of you probably know, is a Pulitzer Prize-winning reporter on energy and the environment at the Washington Post. And he is also now a lecturer at the Yale School of the Environment for this academic year. He's authored 4 books about science, politics, and climate change. And he's a graduate of Yale College, Silliman 99. So on a personal note, I just want to say that we were incredibly excited when we learned of Chris's interest in coming to visit YSC this year, because usually as academics, we're trying to get the attention of journalists. And sometimes they're seeking us out if we're lucky. But it was a real pleasure and a special and unique opportunity to have Chris coming to actually join us, to talk with us, and to learn from each other. So we are really excited and eager to learn more about this story in particular from him and his team at the Washington Post. And without further ado, I'm going to turn it over to you, Chris. Thank you.
Thank you, Jen. And I'm thrilled to be part of the Yale community this year too. It's really wonderful to be back. Hi, everyone. So just a point at the outset. As far as the talk goes, I am a reporter for the Washington Post, but I'm certainly not speaking for the entire publication or for Yale, just me. I'm the one that's responsible for the words and images in this talk. So it's great to be here to talk about some recent reporting that the Post has done as part of a series called Invisible, which is rolling out right now. 2 stories have been published so far. I have a suspicion that there might be another one as soon as next week. And basically what we have found through a series of database investigations so far is that countries appear to be pretty dramatically underreporting their impact on the climate by, roughly some 10 billion tons of greenhouse gases per year. And in order to do this, the Post's analysis drew on satellite and atmospheric analyses of the world's emissions, independent studies of those emissions, and even a data set that we built ourselves. The goal was to hold countries and the world accountable for what they are actually contributing to the warming of the planet. So today I want to tell you how we did that. First, I should underscore this was a pretty big group effort and one that is continuing. So while I am the only one who is actually here speaking with you, this is how many people have worked just on the 2 stories that have published so far, and there are more people working on more stories that are not necessarily having their names listed here yet. So it is a big endeavor, and to do journalism like this, you really do need a large team, and it's really fortunate that we have one. And I'm thrilled to work with all of these very talented colleagues, especially my fellow reporters and data and graphics reporters. A little bit more about me before we start. So I've been a reporter at the Post for 7 years. As you heard, I'm currently also at the School of the Environment for this academic year, and I've been allowed to tag along with the data science initiative and hopefully try to learn some of the techniques that they teach and the students learn. And I think I'm picking up some stuff, so I'm very thrilled. So I spent the 7 years at the Post covering climate change pretty much the whole time. And that included traveling to some pretty distant places around the globe. Here I am on the floating ice shelf of Petermann Glacier in Greenland. But recently, I've been gravitating more towards the sort of amazing possibilities that I think are offered by what I would call data journalism. And this is something you can do without necessarily having to board a military plane and fly to 81 degrees north latitude and then sleep on an ice shelf. But those stories are great and a lot of fun as well. But there's just really a lot you can do in data journalism. What is it? Here's how the field has been defined by one scholar, Bahari Haravi from the University College Dublin, who has written that data journalism turns on, quote, finding stories in data, and that, quote, in data journalism, data is the source. And working with Mirko Lorenz from Data Wrapper, which is a great tool that lets you visualize data, which I certainly use sometimes. The two also documented through a 2017 survey that data journalism techniques have a strong and apparently growing foothold in many newsrooms. Here's some of the data from that survey. So 46% of the journalists that were surveyed said that their publication already had a dedicated data blog section, desk, or team. And certainly that is true of the Washington Post. No wonder this is the case, because in the media, what we want, what we seek, is to find exclusive sources and exclusive information and break news. And what is more exclusive than a data set that nobody else has or no one else has learned how to use or has realized the importance of, a data set that is giving you newsworthy information. And so we first attempted to do a major data project in our climate group at the Post in 2019 with a series called 2 degrees Celsius, which you might have heard of. Many of the same reporters whose names you saw were involved in that in a variety of ways. And we reported from around the world on places that are warming the fastest. And the data element was that we used climate temperature data sets in order to define and identify what the fastest warming places actually were. So we let the data lead us to the stories. Here are some photos from the Sea of Okhotsk, north of Japan, which is warming rapidly. Also from the coast of New England, which has pretty rapid warming occurring. Here's one of the major graphics from the series showing some of the hot spots that are already above 2 degrees Celsius of warming. And this is only through 2018. There's probably more now. We have a couple more years of data. So the Invisible series is sort of the next of these big data projects. And here we're not looking at the world's temperature any longer, but what countries are saying they're emitting in, of course, the anthropogenic activities that are causing that warming to occur. And basically what we did was we drew on publicly available documents filed with the United Nations Framework Convention on Climate Change in order to build a data set that let us investigate what countries are saying about their emissions versus what is really happening. And there we would be looking at other outside data sources and analyses. And along the way, there were a number of sort of more subsidiary analyses also using data that let us really assess what countries are saying and what we could say about whether that was accurate. And I'm going to show you some of those as well. Let me first tell you a little bit more about how this series came about. This dating back before the pandemic actually began, we were thinking about a big project on the world's emissions. And so to contribute to that and advance that, I just started reading a lot of scientific research, trying to figure out where the insights might lie. This is something that I really like to do. I read a lot of science. I find that there's all kinds of insights in the published literature that have not been covered by the media that contain great stories that haven't been told. This is a recurring experience of mine. So I read a lot of science because it's very rewarding. Over time, I became increasingly aware that there were a significant number of studies out there detailing how the world is underestimating the emissions of certain greenhouse gases. And usually it was not so much the carbon dioxide emissions from the burning of fossil fuels, the principal driver of climate change, which we mostly seem to have a pretty good handle on. but it was some of the other gases and some of the other sectors which also contribute a very significant proportion of the problem. And let me just give you a couple brief examples. So here's a recent study about sulfur hexafluoride, which we don't talk about very much. It's an extremely powerful synthetic greenhouse gas, so it doesn't occur naturally. It's something that we make. The US EPA calls it, quote, the most potent greenhouse gas known to date. It's emitted from the electric power industry through certain components of electric transmission systems. What this study shows is that looking at the atmospheric concentrations of sulfur hexafluoride and how they're rising, and then comparing that with what countries say they're emitting, there's a very large discrepancy. There's much more going into the atmosphere than countries acknowledge or take responsibility for. And this is one of many such examples. So here's another study that was influential for me while I was doing the research. It's about the methane emissions from cows. Now, these emissions, like many or most emissions, are often estimated using really simple equations where, to summarize it briefly, you would take the number of cows that are in your country or that you think are in your country, and you multiply that by some coefficient that's called an emissions factor, which is basically an estimate of how much each cow over a year is burping methane, which is going to the atmosphere. But this study suggests that in current industrial agricultural systems where large numbers of animals are raised in close proximity and raised in order to gain weight rapidly, the animals are bigger and they're also often sicker than the standard emissions factors would acknowledge. And so for both reasons, they're probably emitting more than those emission factors might be taking into account. This is just two examples out of many, many that suggest that not only we're not necessarily estimating emissions right, but often when we're estimating incorrectly, we're on the downside. We're too low, not too high. So I was reading this kind of stuff, and at the same time, I became aware of a big quirk in how countries report their greenhouse gases to the United Nations. And this involves something called the managed land proxy, which is complex but really important to our story and to understanding this problem. And what's going on is that countries are claiming really large negative numbers on their balance sheets because of their forests and their land, but principally forests that are storing the most carbon. And so the United States, just to give an example, in its latest report for 2019, subtracts over 800 million tons of carbon dioxide in this way in what's called the LULUCF sector, land use change, and forestry. And the US's subtraction is not even the biggest in the world. China's last report subtracted over 1 billion tons. And this is because of the managed land reporting system. And what that is under the UN rules, countries define how much of their territory is, quote, managed. And that's a term that's open to substantial interpretation. But the United States basically claims all of the US, except for parts of Alaska, is managed. And then they count the greenhouse gas emissions and subtractions or removals that are occurring over this area. And for many of these countries, it ends up being large removals, very large removals. But scientific analyses of the world's emissions often don't come up with the same math that the countries come up with because they're not using the managed land proxy. And what they're saying, and here's an example. So one of the data sets we used, the FAO, UN Food and Agriculture Organization, only credits the United States with negative 232 million in the same year. And the difference is that these data sets are not necessarily giving countries credit for things that they think are not human caused. For instance, if the United States forests are taking up a lot of carbon, a lot of that might be an indirect effect of climate change because we're putting so much CO2 in the atmosphere that plants are growing faster, but that's not really an intentional action like planting a tree. So, the scientific data sets tend to more assume that emissions occur when you cut down trees, subtractions occur when you plant them, but these more natural or indirect factors are not credited to the countries. So this creates another really large discrepancy. So at some point, it kind of dawned on me to ask, what do the world's countries actually report as their emissions, given these kinds of gaps that are out there in the scientific literature? what do the reported emissions actually add up to? Because of course that has a direct bearing on countries' promises to cut emissions. That's why we care. What baseline do the countries think that they're starting from? And how much does that represent what scientists think the baseline is? And once you start to ask that question, it's not really clear how it has been analyzed in the past. Certainly, the United Nations Framework Convention on Climate Change, under which the countries are doing their reporting, it has all of the reports, it has all of the data, but it's not clear that it is actually analyzed it in that way. So I decided to sort of take it on myself. I was pretty intrigued, and I figured I would apply an advanced technique that I've been developing for a number of years. It's called addition. And I also even tried a little bit of subtraction, multiplication, and division in the process. So this was heady stuff. And for some countries, it's actually quite easy. These are the so-called Annex 1 countries, sometimes called the industrialized countries, the developed countries, US, Australia, Japan, Canada, and so on. There are 43 of them. They report every year. They report in exactly the same format, same units. This is the US report, and there's that very large subtraction that I just mentioned from the land use sector. So it's pretty easy to download this stuff, and also it is up to date on the UN website in an online tool that you can just easily use. So that part of the question is simple, and you can sum that up. But then there are the non-Annex 1 or developing countries, and that's an additional 140 plus countries. And here the situation is very different, and it's not easily compatible. These countries don't report every year necessarily, although some do. The data on the UN website are often out of date. So here's Mexico. And the last reported year on the website is 2013. But if you go to a different part of the UN site, you can find 2015. It's there. It's just not in the data set. And that's true for dozens and dozens of countries. So it became clear the job would be to get all the Annex 1 data, and that would give us 2019 emission levels, and then go one by one through the non-Annex 1 countries and just see if the UN data is up to date, or if it isn't, go find the most recent data. And that was where the work came in, because you're sort of digging through these long PDFs and they're not in the same format. And you're trying to find something like what you see here, which is a kind of comprehensive reporting table that shows you the different sectors in which emissions occur and the different gases. And sometimes you don't find that. And then you have to figure out, well, is there another way of getting the data here if you can't just take it from a table where you know how the table works? And one of the most complex things was since there's not a standard format, the reports actually use different interpretations of how strong certain greenhouse gases are. And that really makes a big difference. So if you're hanging out in climate change circles long enough, you will encounter this thing called the global warming potential. And what's going on is this: you want to talk about a country's total greenhouse gases sometimes, not just its carbon dioxide, its methane, its nitrous oxide, but they have different warming effects. So what global warming potentials do is it's a way of converting methane or nitrous oxide to units equivalent to carbon dioxide based on the warming effect over 100 years. But the problem is scientists have changed over time their assessment of how potent methane is over 100 years, or how potent nitrous oxide is over 100 years. So generally, the IPCC, the experts, have been saying that over time, they're thinking methane is stronger and stronger. So they used to say it was 21 times as powerful. They're now saying 28, and in the latest report, they're actually even upping that a little bit more. But nitrous oxide, they've actually said, is a little bit less potent. And I should add that both are rising extremely rapidly in the atmosphere. So knowing their total impact is quite a big deal. But if some countries are thinking that methane is 21 times as powerful and others are reporting it's 28 times as powerful, you can't really reconcile very easily these reports, and the countries are using all different systems. So what you have to do is you have to figure out what system they're using, and then you have to divide by 21 or 25 or what have you in order to get to the common units of methane gas or nitrous oxide gas, or all the fluorinated gases, synthetic gases, so that you can then add them together. So that adds another step. And so it's a lot of work, but we did it. First I did it, then a team, the Washington Post put together, systematically did it, and pretty much, although there were some differences, came up with similar numbers, which is that the countries, if you just take the last year that everyone reported, and that will not be the same year, but if you take the last year, then they're reporting about 41 billion tons of greenhouse gases if you add all the gases together into the common units. So what does that mean? Well, it looks initially like it's not nearly enough, because here's a data set from a group of scientists led by Minks, which we relied on heavily. And this is a scientific data set of what researchers think the world's emissions are, and it's using an influential separate data set called the Edgar data set, and basically saying that the emissions are around 58. So again, I said the countries in their most recent reports are at 41. So that does seem striking, but this is not a perfect comparison. It makes you think that countries are reporting around year 2000 levels, and that seems way too low. There's a couple of reasons that it's not a perfect comparison, one of which is that what you're seeing here, this scientific data set, includes emissions from planes and international shipping, and the countries do not take responsibility for that, so that's not a fair comparison. It brings them a little bit closer. And this is also using yet another set of global warming potentials, the most recent ones from the latest IPCC report that no countries are using. So that also changes the comparison a little bit. But it still shows you something is not adding up. But the analysis isn't finished. You can't just compare these two things. And the reason is that, anyone at this point in the analysis might ask a pretty obvious and fair question, which is, aren't the countries reporting low because they're out of date? You just said that the non-Annex 1 countries don't report every year, and some of the last reports are pretty old. So isn't the gap simply the result of being out of date and time having passed since they last reported? It's a very reasonable question, but when you look at the data closely, it does become clear that while this is an issue, it can only account for a part of the gap, and it's a relatively modest part of the gap. And to show you why that's the case, let's look at the country reporting data itself. Now, these are the last reported emissions for the top 40 emitters. The top 40 emitters defined not by what they say, but by the FAO data set. So this is what the FAO thinks the top 40 emitters were in the year 2019. And this shows a number of interesting things. One of them is that Taiwan is in the list of the top 40 emitters, but there's no Taiwan report to the United Nations. And it's not clear, it does not appear that Taiwan is included within China's report either. So part of the gap actually is apparently Taiwan itself. But anyway, these top 40 countries account for the bulk of all emissions. They report in their last reporting year 37.4 billion. And as I said, the total reporting that we found was 41.3. So this is the large majority. And these countries are not super out of date. If you say 2014 or later, the year of the last China report is not that out of date, at least, then what you find is that in 2014 or later, 35.3 billion tons have been reported. So 85% of all the reported emissions are in 2014 or later. So it doesn't seem like things are way out of date. They certainly are out of date. And I think, Iran, one of the world's largest emitters, having last reported in 2010, clearly, if Iran was reporting today, it would be reporting a much larger number. So you need to do some kind of adjustment. But you need to make sure the adjustment is not too large because the countries are not super out of date. So that's what we did. John Meiskens and Anu Narayan Swamy, two really talented data and graphics reporters at the Post, built a sophisticated model to bring the countries up to 2019 based on how they have reported in the past and what an independent data set, the Minks data set, said about their emissions to try to adjust. And basically the adjustment that they got was about 3 billion tons. And again, this was a pretty cool model, but we checked it through more simple techniques that basically agreed. So one way you can check it is just say, take that external data set, Minks, and take one of the countries, India, last reported in 2016. We know that India's emissions have continued to grow. So what is the Minks data set think that India was emitting in 2016? And what does the Minx data set think India was emitting in 2019? And what's the percent change? And then once you get that percent change, you just raise India's actual report by that percent. And again, that gives you about 3 billion if you do that. So we think that that's probably what the adjustment is. There's no absolute truth in something like this. There's just trying to be reasonable, trying to take into account the passage of time. We did not want to over adjust and sort of fix the gap that we had found, because clearly there are also some systemic things going on with countries underreporting, as the scientific literature shows. So that's essentially the analysis, and then you can figure out the gap looking at 3 independent scientific data sets: FAO, the Global Carbon Project, and the Minx data set. That's where they are in 2019. So we get a gap that is, in the FAO case, over 8 billion and up to 13 billion in the Minx case. There's one other critical point I would make here, which is just that once you've adjusted the countries to try to get some sense of the passage of time and to bring things up to what you think are 2019 levels, the remaining gap then is caused by both groups of countries. It's caused by the developed countries. It's caused by the developing countries. It's not that one group underreports and the other doesn't. After all, we've brought both groups up to what we think is a 2019 level. And indeed, when you look closely, it appears that it is both the developed and developing countries that are missing some emissions. So let's look at where the gap actually is. And this is a figure from our main article about the data. And sure enough, we think that most of the missing emissions are carbon dioxide emissions, because carbon dioxide is the dominant gas. That's not surprising. But we think that they're land sector carbon dioxide emissions, not mainly fossil fuel carbon dioxide emissions, and I'll talk about that more. Second, we think a lot of methane is being missed. Surprisingly, we do not find a significant gap for nitrous oxide, which is actually not what you would expect. And I can't go into why that is, because it's a complicated topic. But I'm not sure the gas is being well tracked. I just think that maybe the errors are offsetting each other. And then there are the fluorinated gases, which are the smallest category, but again, we have underreporting. But the biggest contributor is land use and how that's being reported, we think. And it really does look like a gigantic problem, because as a whole, countries are using the land sector to subtract from their emissions. So basically, you can look at emissions, they call it with and without LULUCF, with and without land. Well, if you add up all the countries and you get your with land and your without land number, the without land number is bigger. Once you put the land in, the number shrinks down to that 41.3. But that's not how the scientific data sets are. They think that land is an addition. Okay, so that is driving a lot of the gap. It's a really big discrepancy. And when it comes to land and forests, I mean, one of the key things you have to think about is that this is just hard stuff. It's not like fossil fuel burning, where when you're trying to figure out what the emissions are, you're just dealing with the physics of combustion. So there's this much gas in the tank. We know that pretty precisely, so we know that this is how much carbon dioxide is coming out of the tailpipe. Biology is a lot more complicated than that. Carbon goes into plants while they grow. It goes out of them again as they die, or they burn, or if there's a drought. So the carbon is moving in 2 directions, and the scientific uncertainty is high. So it's not a surprise to find a gap here, but the magnitude of it is surprising and concerning. Let's talk about one place where we think the gap exists. This is an image of a orderly palm oil plantation in Malaysia. And Malaysia is a country that we think definitely there's underreporting going on, and that it's pretty significant. It's a country that, like Indonesia next door, has seen enormous land use transformation, much of it driven by the palm oil industry. And basically, what you have is these really carbon-dense landscapes. They're called peat swamp forests. And they are cleared, and that means you're removing the trees, but then they're also drained. So this is a boggy, swampy landscape with a lot of carbon in the wet ground, but that water is drained out. And once that occurs, the peat that remains starts to oxidize and starts to emit carbon dioxide, and that goes on for decades. And so peatlands are some of the most carbon intensive types of landscapes. And this process, scientists think, is really unlocks a great deal of emissions. So when you look then at the reporting from Malaysia, a number of things jumped out to us, but this is one thing that was really striking. So what I did here is I just plotted the data from Malaysia and 9 other countries in Southeast Asia based on how much carbon they say their forests are storing in the latest report, and then the total forest area that they report. So the dots are colored differently based on the year of reporting, because some of this is really out of date and some of it isn't. Malaysia, Vietnam, Thailand, and Indonesia are all 2016, but the rest are sometimes substantially older, including Philippines and Myanmar are quite old. Cambodia is not there because it doesn't claim that its forests are storing carbon. It actually says they're losing them. So what you see is a relationship between the size of your forest area and how much carbon you say is being stored, and that shouldn't really be surprising, because the more acres of trees you have, the more trees that are growing, the more carbon is being stored away. I mean, that is clearly one, not the only determining factor. The type of trees matter and so forth, but it's clearly one important determining factor in how much carbon is being stored. So you would expect this somewhat linear looking relationship to occur, but Malaysia sort of jumps out because the forest is not as big as some of the other countries, but the amount of carbon stored that is being claimed to be stored is quite big, and it's almost as big as Indonesia, but the forest in Indonesia is 5 times larger. The other outlier is Papua New Guinea, but there it's for the opposite reason. The country has a large forest, but it's not claiming much carbon storage. So for whatever reason, I haven't analyzed it. It's not the same kind of issue, if it's an issue. And the effect of this gigantic carbon storage claim has a major effect on Malaysia's reported emissions, which, when you take land into account, they're only 81 million tons in 2016. But the FAO again puts the country at 422 million. So that would mean definitely in the top 40 and comparable to Turkey, Pakistan, Argentina, sort of a mid-sized but major emitter. Whereas the number Malaysia is giving is sort of more of a smaller size European country like Austria or Greece or something like that. So it's really, really quite a big gap, which is why we focused on it so much. So seeing data like this make you wonder what's going on, and it turns out that the experts who review some of these reports had problems with it too. This is a review of Malaysia's documents filed with the RED Plus program, which is about reducing emissions from deforestation and forest degradation, and they're talking about the claimed forest carbon sink or sequestration, and the experts say this is an unusually large figure. Transparent information is needed to justify it, and they go on to say that they tried to reproduce it using 3 separate methods and could not reproduce it. All their methods resulted in much smaller amounts of removals than the country reported. It's not the only thing that's going on. Another thing that's happening in Malaysia is that the reports say that there are no emissions from land being converted from forest to cropland or from other types of land to cropland, but you can see in satellites that that's occurring. So the first image is a 2015 image of a palm oil plantation, and you can see that by 2016 it expands, and the images were captured by Planet Labs, but we knew where to look because there's actually a scientific study about this very conversion of land, and it was on peatland. The researchers reported. So peatland was drained here, and they reported that there were large emissions from the conversion process. So it just looks like in this case, there certainly appear to be a lot of issues with the country's reports about the land sector. Now, we think these issues are widespread. In some cases, we think that the countries are claiming land is drawing up carbon, and that is happening, but it's a question of whether it's human cause and whether the countries have responsibility for it. And the scientific data sets often think that they don't have responsibility for it. But there are also, we think, cases where carbon storage is being overstated, or emissions from land use change, like from peatland drainage, are being underestimated. So we just think there's a lot of problems there. And then the second part of the gap is involving methane. Compared to the scientific data sets, countries are reporting tens of millions of tons fewer methane emissions. And so it's the second biggest discrepancy in the data. We think it's happening in rich and poor, or developed and developing countries alike. A lot of it has to do with oil and gas leaks, but not all of it. There's also the agricultural sector, livestock emissions, a lot of methane there. There's the waste sector, landfills, and it just seems like the gas is being undercounted across the board. It's just an elusive greenhouse gas, and it seems like the methods for estimating it are often failing. But at the same time, new methods are coming online. We've got satellites that can detect methane leaks and put on record events that might have gone unnoticed before. And so we drew on that kind of data in the first story in the series, which was about methane from the oil and gas sector in Russia and the considerable evidence that the estimates that the country is giving are too low. I'm going to show you a little bit of that data, but just to be clear, it's not like Russia is the only country where the underreporting is occurring. I mean, this has been documented in the United States. It exists in the Middle East. Multiple stories suggest Central Asia. Just a lot of oil and gas producing regions seem to not be capturing the full methane leaks. And that is for a variety of reasons. But again, it comes back to this issue often of emissions factors and just estimates for how much leakage occurs given a particular amount of oil and gas activity. It's just a really kind of a blunt approach, and it doesn't really get the complexity of what's happening and the fact that some leaks can be really quite large, can be undetected, can go on for a long time. And that's what the satellites are allowing us to now see. So if you take what Russia reports as its emissions, and then you compare that with satellite and atmospheric analyses, you certainly see a gap. So this is the 2017 fossil fuel methane. Russia is the red column, and then there's 16 atmospheric or satellite-based inversion models. An inversion model is where scientists basically measure the gas, either from space or through some type of atmospheric measurement, and then they run a model to try to figure out what they think the sources are, where it's coming from. And then they can try to attribute that to a country or to some other large area of land, what have you. As you can see, there are a few inversion models that come up with low results that are similar to the countries, but the majority are considerably higher, and the median is considerably higher. And a variety of independent data sets that we consulted, some of which don't use satellite techniques, but use different approaches, all give higher figures. And we also asked experts running these kind of models from Harvard and the Environmental Defense Fund to conduct an additional analysis just for us, and they ran multiple inversions. And again, they came to the conclusion that the emissions are probably twice as high. I'm not saying that this is the only country in which this is true. I'm saying it's a widespread problem. And we sort of think that we pulled together all the evidence in this one particular place. We did get responses from Malaysia and Russia. And interestingly, one common theme was that the country said, we follow the reporting rules. There are guidelines. They're very extensive. There's review. All of this is true. But the system itself does nevertheless seem to be producing reports that are too low. And yes, I agree that the system does have rules and guidelines. There's also a lot of flexibility for what you do within the guidelines. And so countries can come up with different answers by picking different emissions factors, by picking different global warming potentials like you saw. They get to choose those things. So there's definitely some subjectivity also built into the system. So what does it all mean? It's on the Paris Agreement's docket to get better emissions reporting in place by 2024, at least initially. This is called the Enhanced Transparency Initiative, and every country is going to have to report by the end of 2024 more regularly and in more of a uniform format. And certainly that's a very good thing given what we experienced trying to pull together the data. There's no doubt about that. But it's going to take a lot of time getting used to, and so it's not necessarily going to work right away. And it's not clear whether if countries use the same methods, just being in a uniform format and being more timely probably will not fix all of the problems and all of the underestimates. So it's a good step, but it's probably not the whole step. Another key question is, what does all of this underreporting mean for the country's promises? I think that's what we all care about the most. And I cannot give you a precise answer because that's an entirely separate analysis that would require going through another 190 documents, all of which are in different formats. But it's not, I don't think it's going to be good news unless you think that emissions that are going underestimated or unreported entirely are going to be cut just as at the same rate as emissions that are reported. then you would have to be concerned about countries' promises. And I think it's unlikely that emissions that are hard to track to begin with are going to be easy to cut. I think it's probably likely to be the opposite. And the land problem is definitely going to loom larger and larger as we try to implement the Paris Agreement and get into a regime where everybody's emissions are actually going down according to their reports. Because if you get into that world, we're not there yet, but when you do, it's clear that countries with large areas like the US, Russia, China have a real advantage because of the way that the land system works. And they're going to be tempted to claim that they are, quote, net zero because the land is taking up so much carbon. Even though they're still emitting a lot of greenhouse gases, they're going to apply the subtraction against the positive number and get to zero. We're not seeing a lot of that yet, but you can see that it will, at least under the current reporting system, it's going to come up. And so there's going to be major issues about how net zero pledges are interpreted due to the way that land is being reported. So I guess what I'm saying is transparency is great. Transparency is very important. But what does it mean? Does it mean that countries are more timely and reporting in more uniform formats and giving all the data behind how they do the calculations? That's good. But we need another kind of transparency too, which is independent analyses of what's going on. So we need more integration of satellite data into the reporting process and more independent assessments of what's really going on with the land sector, with methane, all the rest. And that, I think, is how you would patch up some of the gaps that we talked about. So I think I will end there, but I will probably have some questions. So thank you very much.
Thank you so much, Chris. That was incredible reporting, an amazing amount of work and research, and a bit disturbing, but really important. And we have some really excellent questions. I want to thank the participants for putting your questions in the Q&A. And I am going to dive into them and try to hit a lot of them, but we have many. And so let me just start by asking one general one. Actually, this is building off of a question from Alexandra Bell about, the fact that this has been out for a few weeks now, and you talk about steps already underway to correct the process and improve the process. But have you had any more specific feedback? What has the reaction been to this and the impact?
Well, we do hear that this article, especially the second one, I mean, the one about Russia was the first one, was widely read and was talked about a lot in Glasgow. And yes, the United Nations Framework Convention on Climate Change is definitely aware. I mean, we were talking to them while we were doing the analysis and shared the numbers with them. So I do think that this story may have some impact. Exactly, there's no impact that can be pointed to at the moment, but yeah, it's been out about a month. So.
Mm-hmm. And it sounds like you alluded to the fact that you can't sort of calculate the ultimate impact. But do you think there will be further attempts to take this and see what is the impact on temperature projections ultimately?
I would hope so. I'd like to see what that results in. I think that requires another set of numerous steps that are a bit beyond me. But I do think that, not a bit beyond me, they're way beyond me, but I do think it is important to know what that is. But the land is going to be a little bit different than the other parts. But in terms of the urgency of addressing warming, the methane is really quite key, because we know that a lot of the warming we're currently experiencing, methane doesn't last that long in the atmosphere. It lasts some 10 years or something like that. But it hits hard when it's emitted. And so a lot of the present warming is not CO2, a lot of it's methane. And that's why people are targeting methane so heavily right now and trying to cut it fast. But if it's underreported, that's going to be hard to do. So there's a lot of policy that has to happen with regard to methane emissions. And land has a whole different set of implications for the warming of the planet that they get more complex. But yes, I think it raises that question.
There was someone wrote in, Carla Schultz about the potential of methane and how you measure it, whether it's 35 times the amount or 21 times the amount. Did you have that debate internally about how to report it? Because depending on the base year that you use, this is getting a little bit technical, but it's important and it has implications for how we think about how potent methane is. And Carla provided some numbers and was just pointing out that it should be 87 times the amount of when you calculate it on a basis of 20 years or 35 times on the basis of 100 years. What was the discussion like that? And do you think about that when you're reporting it?
Right. So there's the global warming potential number they call it GWP 100, and then GWP 20. And so one is what do we think methane is compared to carbon dioxide over 100 years, and one is what do we think it is over 20. If you take the 20, then methane gets way more powerful, and if you take the 100, it becomes less, although it's still more powerful. We went with 100, and we went with the AR5 28 for our analysis. 28 times as powerful. The reason we did that is because no country is reporting the 20-year. Nobody uses that in reporting. Now, it's certainly true that it's more potent. The shorter the time frame is because the gas is mostly gone in like a decade. So yeah, but in reporting, no one does that. So that's why we didn't do it. But you can definitely assess the strength differently depending upon the time frame. There's no doubt about that.
Mm-hmm. Mm-hmm. So a question here from Kurt Newton is about this, the land, the contribution of land use change, LULUCF, you're calling it, land use change, and these reporting gaps. They have huge implications, of course, for all of the efforts by companies and governments to offset their emissions. And so how do you think about that? What are the implications going to be for carbon offsets and that entire endeavor?
Well, a wise researcher who I don't think was on the record, so I'll just paraphrase, I had a long chat with this person about this. And I mean, it seems to me that the issue for both countries and companies or anyone else trying to buy offsets is additionality. In other words, if you want whatever, carbon storage that you're claiming or paying for or whatever, you want it to be something that wouldn't happen otherwise, except for a human taking an action, right? And my understanding is that there are, although I'm no expert on this, there are certainly pretty sophisticated attempts to try to document additionality for a lot of the offsets. What's happening with countries is that that's not the standard, and that's why the problem exists. So there is something that is clearly not additional is the CO2 fertilization effect. All this CO2 that we put in the air is causing plants to grow, and that is showing up in however you measure the carbon storage in the world's forests. But I don't think we want countries taking credit for it. It seems like a strange thing to be taking credit for. Also, there is all this natural recovery of forests from events long ago that is mixed in here. And it's also something we don't want countries necessarily taking credit for. So it seems important that the countries take additional actions to cause their land to store more than it would have otherwise, and that is a human caused and deliberate thing. I mean, basically, that's how I'm thinking about it.
And do you, other than publishing this in the Washington Post, which clearly reaches a very large audience, do you use other channels to disseminate this work? And do you ever reach out to policymakers, to the YPCCC, make sure that they're seeing this?
Well, we reach out in the sense that with a story like this, it is mandatory to get their response. And
Right.
so we did.
Mhm.
And that was not just one exchange. That was a long series of many, many emails sharing various things that we've done. So I think that it's by definition, it's our job to put it on the radar of the in this case the international body that's managing the reporting and the Paris Agreement. So that we did that. I don't know what you mean in terms of like would we push further for change beyond that. I think we sort of let our reporting speak for itself at that point.
Yeah,
Yes.
it makes some questions are coming in about the role. You know, this definitely sparks additional levels of concern, and I think you know, do you have thoughts about so there are questions about specific countries, like it seems like you could spur the development of entire dissertations on individual countries at this point to go into what's going on in these different specific cases. And so there is clearly a role for scientists here. There's a role for more data journalism, and there's a role for the public. And the story about you know, where some of these big emissions are coming from, I think kind of downplays the role of the public in some ways. But what is your reaction to that? Did it change your thinking about the role of individual countries taking more responsibility, you know, international processes versus the role of individuals and the public? What can individuals do with something like this?
Well, I mean, data is powerful, and one thing individuals can do, the more this information is available, the more transparency we have, the more people can ask questions, and that's I think a really important aspect of this. So I think that we, given that the planet is warming very, very fast, and we're extremely concerned that our children are going to live in a very, very different, potentially more difficult world, it is absolutely fair for us to demand that the countries that contribute the most, and it is really a relatively small group of countries that are contributing the most. But you know, all countries as they come into the Paris system, but you know, the major emitters are definitely more important, that they really document in great detail what they're doing, that it is subject to transparent review, and I think it has to be subject to, you know, external analysis, which is not really currently built in to the way that reporting goes. I think a lot of this is that the reporting system was built, you know, decades ago. Some of the emissions factors are quite old, and we're learning that sometimes things are just more complicated than that. But the countries are still using a system that just doesn't adequately capture what's going on.
So this, I mean, this is very much how scientific research works. Right? I mean, you're doing scientific research in many ways. How do you see this intersecting between, what's the difference? And is there a model for more of this kind of work on the side of these, you know, large media and publishing organizations taking on more of this scientific and real investigative journalism, because you have abilities and responsibilities that are different. They overlap a little bit with scientists, but they're quite different. So how do you see that evolving?
Yeah, I mean, so we got very close to scientists in the course of these big data projects. We get to the point of sharing methods and data. We got an expert review from many different researchers of this, because we had to. It is in a space that it's within the media's reach to do, but it is certainly something that is also within the scientific world's remit. But it's something we can do because basically most of it is, as I said, addition. It's just a lot of addition, and finding the information is much harder than the addition. But the issue is that journalists in these shared areas, which I think this is, right? It's working with data. It's not insurmountable for us to work with it. Certainly, scientists know how to work with it. It's a case where we're asking different questions, and so for whatever reason, the question for us was, what did the countries actually say? Because we sort of want to fact check that. We want to truth squad it. Whereas I think scientists, I'm not speaking for any of them, but my impression is that part of this is that they knew that the data were bad and thought, well, why use it? I mean, we need to have the right data on what the emissions are. So in some sense, that was sort of seen as, well, we know that the countries are reporting, but there's a lot of problems, so we're just going to do the analysis differently. And so therefore they built these wonderful data sets, which we then could use. But as a result, I don't think that there was this kind of digging that we did into what's actually being said, because we're asking different questions. Now, I think that there has been some looks at it besides ours, for sure, and I think it's increasing. And we were really influenced by a number of studies that are starting to do direct comparisons between country reports and satellite inversions in a specific region. And that's only going to increase because more and more satellites are going to be going up, and they're going to have increased capacities. And so people are going to keep finding these discrepancies. And it's going to raise a lot of questions about the process unless it's taken into account somehow.
Thank you. I think Lisa, are we nearing time? We are at time here. Let me just say, this is really incredible reporting, Chris. It's so important, and we really appreciate you sharing it with us. So thank you so much, and look forward to
happy to be here, and I'm just glad to be part of the community here, and thank you for your interest. And yeah, your kind words about the story. Thank you.
Thank you very much to both of you. Chris, this is just incredible. And I think there's going to be a lot of follow-up. I mean, just looking at the Q&A, there's tremendous interest in how the public can take this forward and create pressure on the official bodies that are responsible for this reporting at the country level. And then also, of course, at the YPCCC and the UNFCCC. So of course, as you well know, it's not the end of this at all. It's just the very beginning. And thank you so much for sharing it with us, both at the meta level, you know, your role as a reporter, and then just all that data analysis, just an incredible work. Just want to say thank you so much for joining us, everyone. This was the final event of the YCEC Fall Speaker Series. We will be back in January with a review, actually relatedly, of COP26 from sort of a public diplomacy perspective. And that will be on January 28th. We have Sue Biniaz, who is also a lecturer at the Yale Law School and at YSE, who will moderate that. And we're working on a panelist both from the media side and somebody who participated in the diplomatic effort. So that should be super, super interesting. And just to say logistically, everyone who registered for this webinar will be getting a follow-up email. It will take a little while. Don't look for it to land in your inboxes for probably about a week. We have to edit the YouTube recording, and that will go out to everyone, and we'll have it posted on our website as well. That's climatecommunication.yale.edu. Thanks very much for joining us, and happy holidays to everyone.